Hi, ESS folks. It's Ms. Lenorvitz, and I'm just going to talk you through a couple of your next analysis steps for your greenhouse effect lab. So you're going to be doing this analysis, which is a PA, so you want to make sure you're doing it well. We'll talk about this in class as well, but you're going to start off. The first piece is going to be your data table. For this, I want you to include your team's final data table showing your raw data that you collected for the temperature of your control and your experimental bottle as you heated them up over 15 minutes so that we can see those actual temperatures here. So you're just going to go back through and copy and paste from your original spreadsheet right into this document. When you do that, make sure you select to link to your spreadsheet so it will automatically update here. The second job that you have is to do some calculations, and many of you have done these already in class. You're just going to re-show your work and your final answers here. So again, you're going to use your team's data, your trials, and you're going to calculate for each bottle the total temperature change during heating. So that's the highest temperature minus the starting temperature. And then you're also going to calculate the percent change in heating. So that is the final temperature minus the initial temperature. Calculate that and hit equals. Remember those math operations orders. And then you're going to divide that by your initial temperature, hit equals again, and then you'll multiply that by 100. So if you can record both your work and your final answer there. In the next step, you're going to construct a graph. Your graph you are going to construct using our class data. And that's what the next steps of this video are going to cover, is how to work with that really big data set to first do some calculations to make it more manageable to graph, and then how to do that graphing. Remember that something that's going to be helpful for you as you're graphing now and into the future is the Here's How guide to construct graphs. So you know, and you've used this before, that this applies whether you're constructing a graph on paper, so an actual graph paper by hand, or whether you're constructing it in Google Sheets, which is what you're going to do today. So you know you need to make sure that each axis is labeled with the correct variable and units, that you need to determine the best type of data to graph. In this case, you're going to have to make a choice. You need to determine the best type of graph to show that. You need to make sure each axis on your graph has a consistent scale to maximize representing your data. You need to plot the data, and then you need to have a good title for your graph that represents the relationship between the variables on your Y and your X axis. On the back side of that handout, or on this next page, you're going to see the directions for how to do this in Google Sheets. I'm going to cover this in this video, but you can go back and look at this step by step in case there's something that you need to go back and review. All right, here we're looking at all of my class's data. So there have been 19 successful trials of doing this experiment, and all of that data is represented there. Now, if you had to graph all of this data, it's going to get pretty busy, right? There are a lot of values there. So you're going to have to make some decisions and selections about how to approach this. The advantage of having lots of trials is that we have more confidence in our data, but it also makes it difficult to show. So one of the strategies that we often use when we have lots of replicates is to find the average. You know that in order to find the average, you add up all of the values that you have, and then you divide it by the number of values. So in this case, we would be adding up in the control bottle all of the temperature changes in the control bottle, and then we'd hit equals and divide by 19. You can absolutely approach that this way, but that's a lot of numbers to put into your calculator and keep track of without making a math calculation error. So I want to show you another way that you can do that in Google Sheets that will be helpful both for this lab and for future work as well. Google Sheets, like Excel, is a spreadsheet, which means not only does it have these rows and columns for you to keep track of information, but it also knows how to do some pretty simple commands. So we're actually going to tell it that we would like to calculate the average of all of the values that are right here from trial 1 through 19 for the total temperature change in our control bottle. How do you do that? Well, I'm going to click in this cell right here because that's where I want that value to go, and I'm going to enter in an equal sign. That's the cue to Google Sheets that I would like to have it do an equation or a calculation. You'll see that it's already prompting me because I've done this once before, and then I'm going to type in a command. I'm going to type in average because I would like to calculate the average, and then I'm going to put in an open bracket. I'm then going to take my cursor and go up to the top cell that I'd like it to include, and drag it all the way down to the last data point that I want to include. I'm now going to put a closed parentheses on that to tell it that I want it to calculate the average of all of the values that are between B2 and B20. Once I'm satisfied with my equation, I'm going to hit enter, and you can see that it did that calculation for me. You can repeat that process with any other data set in your data table. So you'll see here I calculated the average for each one of those columns. So now I have some more consolidated data that I can use when I'm graphing. So the next step I need to take is to actually tell Google Sheets how I want it to make this graph. Hopefully you're already envisioning what your graph is going to look like. Remember that your x-axis is going to represent your independent variable, and your y-axis typically represents your dependent variable. In this case, think back in our experiment, what is the variable that we purposefully changed? And what is the variable that we measured the response in? In this case, the variable that we purposefully changed was the amount of carbon dioxide. And the responding variable, the dependent variable, was the average total temperature change. The amount of carbon dioxide was varied. In our control bottle, it was low. In an experimental bottle, we added extra carbon dioxide. On our dependent variable, I'm going to put in the average total temperature change for each one of those. So down here you can see that our average in this case for our controlled bottle was a temperature change of 10.6 degrees Celsius. And our average for the experimental bottle where we added extra carbon dioxide was 15.4 degrees Celsius. Notice how in here I've put my heading. That includes both the variable and when present the units. From there, I'm now ready to tell Google Sheets to make a graph. When you graph in Google Sheets, it's going to assume that the data that you have in the first column is going to go on your x-axis. So you want that to be your independent variable. I'm envisioning in this case, since I have categories on my independent variable and I have numerical values on my dependent variable or y-axis, that this is probably going to be best represented as a bar graph or a chart. You want to have that picture in mind before you make your selection. Google Sheets will try to guess what you want, but it isn't always correct. So once I have my data selected, my x-axis and y-axis data, there are lots of ways you can do this, but I'm going to go to Insert and Chart. And then a menu is going to pop up for me. I'm going to scoot this over so that we can look at it a little bit more carefully without so much traffic on the page here. So you will notice that Google Sheet made a guess, in this case was right, that I wanted a column chart. But in order to change that, you would go to Chart Setup, and here is where you're going to choose different types. We do want a column chart, so that's what we're going to start with. It will also then take advantage of the work that we've already done. So notice, because I put in a good column heading in my data table, amount of carbon dioxide, it made that my x-axis label. On my y-axis label, it took the label that I put in my data table. So that's why having a heading with the variable and the units is really helpful. It also then made an assumption and created a title for this graph. So it took the average total temperature change, my y-axis label, inserted the abbreviation versus, and then put amount of carbon dioxide. This particular setup would meet proficiency. You can certainly get more sophisticated with your title to better describe the context of the data that we collected. So hopefully that was helpful in terms of how to calculate data in Google Sheets and then how to construct a graph.